I am Jahangir Abbas, lecturer in chemistry. In this video lecture, you can understand how coordination compounds are named. I will discuss here rules for the nomenclature of coordination compounds. Firstly, we will discuss how to write formula of a coordination compound. Formula of coordination compound is written in such a way that firstly we will write the formula of K10. If complex compound contain two components, K10 and anion, K10 is written firstly and anionic part is written after the cationic part. Like in this complex, sodium is cationic part. K10 is written first, while the second part, the anionic part, is written after the cationic part. The formula of K10, whether it is simple or complex, is written first, followed by the formula of anion. Like in this complex, sodium is written firstly, and after the sodium, anionic part is written. Within a coordination sphere, the metal atom as well as the ligands are listed without any space between them. This bracket part is a complex part. In a complex part, there are two components, ligands and central metal atom. There is no space between the ligands. In the formula of charge coordination entity is to be written without a constant. The charge is indicated outside the square brackets. The charge is indicated outside the square bracket as right superscript with the number before sign. That has a -2 charge. We will write this charge on the top of square bracket. Firstly, we will write the number 2 and then the charge. The charge of K10 is balanced by the anion in a complex. How to name coordination compound? Always name of K10 appear first and then anion is named. For example, in this complex, there are two parts. In this coordination compound, there are two parts. Potassium is cationic part of coordination compound, and FeCN6 is anionic part of coordination compound. During the nomenclature, we will name cationic part first, potassium, and after naming the cationic part, we will name the anionic part. Whether there is simple cationic part or complex cationic part, always we will name cationic part first. As we know, there are two types of species in a complex part. The complex part of a coordination compound. These are ligands and central metal atom. When we will name complex part of a coordination compound, complex part is indicated by the brackets. We will name the complex part of a coordination compound. There are two types of species, ligands and central metal. Ligands are named before the metal. If more than one types of ligands are present, then ligands are listed alphabetically. Like in this complex, there is cobalt, central metal, amine, and fluoro are the ligands. We will name ligands first, and there are two ligands, we will name amine first. There are 5 number of amine molecules. We will write pentamine and then fluoro, and then central metal atom is named cobalt. Ligands are named for metal, and ligand, if more than one ligands are present, then ligands are listed alphabetically. Naming of ligands. There are 3 types of ligands. Names of anionic ligands end in O, and the ending of names of neutral ligands are not changed. For example, CO3 2-, that is a carbonate. When we will write the name of carbonate as a ligand, then we will write as carbonate. Oxalate is a ligand. If oxalate is a ligand, we will write as oxalate. In the same way, sulfate, SO4, 2-, that is written as sulfate. All the anionic ligands, when named, these end in O. Neutral ligands are named as such. We will not change the name of neutral ligands. For example, ethylene diamine. Or there are some exceptions like water. Water is named as aqua. NH3 is named as amine. Cationic ligands are named as follows. First is named as nitrosamine. If more than one ligands are present, and Greek prefixes are used, like di for 2 ligands, di for 3, tetra for 4, tetra for 5, and for 6. If this Greek prefix is already present in the name of ligand, then we will use alternate prefixes, like this for 2 ligands, this for 3, tetra is for 4, penta is for 5, hexa is for 6. In this complex, there is a ligand ethylene diamine and fluoro. As we have studied, we have discussed the rule. Ligands are named alphabetically, like fluoro. When we will write the name of ethylene diamine, there are 2 ethylene diamine ligands. We will not use prefix di for the name ethylene diamine, because di is already used in its name. We will use alternate prefix. This is ethylene diamine, platinum, or fluoride. In this way we have studied. We use prefixes for more than one ligands, di for 2, di for 3, up to so on. If already there is present such prefix in the name of ligand, then we will use alternate prefix. Like ethylene diamine, there is already used prefix di. In ethylene diamine, there is already used di in its name. We will not use di again, we will use this instead of that. If complex, there are 3 types of complexes: anionic, cationic, and neutral complexes. If complex is anionic, Then we will change the name of central metal. If complex is neutral or platonic, then there is no change in the name of central. These are examples of any complexes when we name the central metal atom. We will change its name. In this complex, platonic part is potassium. We have written the name of potassium. In this complex, platonic part is potassium. But there are two types of species, ligands as well as central. Ligands are named first, tetracyano, and when we will name central metal, that is in any complex, we will write Aure instead of gold or organ. Aure 2 and N is written because this coordination compound have negative. The same way in this complex, we will change the name of central metal by equal because it is in a complex. These are metals when complex will be platonic or neutral. We will not change the name of these metals. But when there is in any complex, we will change the name of central metal and we will write AT at the end of the central metal. How to write oxidation number of central metal? When we name the central metal, then we will write its oxidation number in Roman numbers. As we have discussed the rules of naming coordination compounds, platonic part is named firstly sodium, and then ionic part is named. Ionic part contains two types of species because it is a complex part. It contains central metal ligands. Ligands will be named first. There are two types of ligands present in this complex. We will name alphabetically. Fluoro will be named firstly, then after. Tetrafluoro, oxo. This is an anionic complex. We will change the name of central metal atom. We will write AT at the end of central metal atom, and then we will write its oxidation state, oxidation number. Oxidation state is written Roman numbers. As there is oxidation state plus 4, we have written it in Roman numbers. How to find oxidation state of central metal? This is a complex. We have to find oxidation state of central metal, and how? We will write the oxidation states of other species. Sodium, oxidation state of sodium +1. There are two atoms, 2 and 2 +1. Plus, we have to find oxidation state of central metal atom X plus oxidation state of oxo -2 plus oxidation state of chlorine -1 into 4 is equal to 0. Then we will calculate the oxidation state +4. We will write it in Roman numbers. We see this complex. We have to find oxidation state of Fe X. We have written it X hydroxo -1 plus oxidation state of water is 0. 5 into 0 is equal to charge plus. Then we calculate the oxidation state of air, and that is +3. When we will name it, we will write in Roman numbers. There are two types of ligands. Water is named firstly aqua because ligands are named alphabetically. Penta, aqua, hydroxo, Era. We have not changed the name of central metal atom because it is platonic complex. Only the name of central metal atom is changed when there is ionic. There are some monodentate ligands that can coordinate with the central metal atom by two different atoms, because these ligands have two donor atoms, but these are monodentate, unidentate. This time only one of the atom can donate electron pair for the formation of coordinate pole. For example, SCN. In this ligand, it is coordinating through sulfur with the central metal, and NCS. In this ligand, it is coordinating through nitrogen. The same way, NO2 nitro, ONO nitride. In this ligand will coordinate through nitrogen with the central metal, and this ligand will coordinate through oxygen with the central metal. So these may have different names like thiocyanate or isothiocyanate, or we will place the symbol of donor atom again. Like for this ligand we will write S, and for this ligand we will write N. There are two ways for naming such ligands. These may have two different names, like when this will coordinate through sulfur, we will name it as thiocyanate, and when this will coordinate through nitrogen, we will name it as isothiocyanate. When this will coordinate through nitrogen atom, we will name it as isothiocyanate. We can also name these ligands as by placing the symbol of donor atom. When this will coordinate, we will write as S, and when this will coordinate with the central atom, we will write as N. Now we discuss the rules for naming polynuclear complexes. If a complex contains two or more central metal atoms, it is termed as polynuclear. In certain polynuclear complexes, ligand may link two metal atoms. Such ligand which link two metal atoms or ions in polynuclear complexes are termed as bridge ligands. These bridge ligands are separated by the rest of the complexes by hyphen and cremated by prefix big. I will see the example. If there are two or more bridge groups of the same kind, this is indicated by tri. This is a complex. It has a bridge ligand. This is the complex. It has a bridge ligand OH that is coordinating with two metal atoms. When we name this complex, cationic part is named first. This part will be named first. It contains hydroxy as a bridge ligand. We will write bu hydroxy. Then we will write the remaining. We will name the remaining part bis, because there are 5 amine with chromium. In this side there are 5 amine with chromium. We will write bis for these 4. Bis pentamine chromium 3 chloride. We have in the bridge ligand hydroxyl. Then we have this pentamine chromium 3 chloride. We will see this complex. There are two different bridge ligands, mu amido, mu hydroxyl. octaamine dicobalt 3N. We can name this complex like this. We can use here this tetramine cobalt 3N like this. There are two different ways to name these complexes. We can use this. These are some examples of coordination compounds. In this complex, lithium is the cationic part. We will name cationic part first, lithium, and then we will name the anionic. Anionic part contains two components because anionic part is a complex part. It contains central metal atom and ligands. Ligands are named firstly tetrahydroaluminate because it is anionic complex, so we have written it as lithium. In this complex, sodium is the cationic part. We have write sodium. You should understand that we will not write tri, tetra, di for the metals that are present outside the complex. We will not write di, tri, tetra for the species cationic or anionic that are present outside the complex part. Only di, tri, tetra is used for the ligands that are present in the complex. Sodium. There are two types of species. We will name the ligand firstly hexanitrito and cobaltate. N represent the atom of coordinate, that is coordinating with the central metal atom. Nitrogen is coordinating. We have write N cobaltate. The same way here cationic part is complex part. We will name the cationic part firstly. It contains two types of species. Ligands are named firstly diamine, silver. We have not changed the name of central metal atom because it is cationic complex. Name of central metal atom is changed when there is anionic complex. Silver 1 oxidation state and nitrate. We will not write it nitrate. We will not write it nitrate. It will be named as nitrate, and this will be the ligand. And ligands are always present inside the bracket. When it is outside the bracket, we will not write nitrate. We will simply write nitrate. This is a complex. Potassium is cationic part. Potassium tetracyanurate. We have changed the name of central metal atom because it is anionic complex, and we have this has charge, so we will write it as N. These are some examples. We will name cationic part firstly. This is the cationic part. Cationic part is the complex part. There are two types of species, ligands as well as central metal atom. We will name ligands firstly. There are two types of ligands. Ligands are named alphabetically. Amine is named firstly. Pentamine, fluoroplatinum. We have not changed the name of central metal atom because that is cationic complex and its oxidation state 4 and bromide. You should understand that we will not write it as bromine. We will not name when bromine is inside the complex part, it will be named as bromine. But when it is outside the complex part, it is named as bromine. In the same way, when chlorine is inside the bracket, it will be ligand. Ligand is not present outside the bracket. And we have not write Tribromide. Tri is used when this bromine, if this bromine is present inside the complex, it is ligand, then we will write it tribrom. If it is outside the complex part, it is written as bromide. In the same way, we see this complex triamine, triaqua, chromium 3, chloride. We have not write it as chloro, not trichloro, not trichloride, because it is not a ligand. It is outside the complex part. There are some other examples. You can see these examples and can understand the nomenclature. You can understand the nomenclature.